The deepest vertical hole humanity has ever drilled is 12,262 meters deep. That sounds like a journey into the planet. But compared with Earth itself, it is barely a scratch, only about 0.19% of the planet's mean radius. After more than 2 decades of drilling, the project was still inside the continental crust. This was the Kola Superdeep Borehole, known as SG-3, on Russia's Kola Peninsula. Drilling began in 1970 as a scientific project. The goal was not oil or gas. Researchers wanted direct samples from ancient continental rock and planned to reach 15 kilometers. In 1989, one branch reached 12,262 meters, establishing the record for the deepest vertical borehole. There is an important distinction here. Some modern oil wells have a greater measured length because they curve sideways. Kola's record is true vertical depth, how far below the surface the bottom lies. Its narrow branches descended through rock more than 7.5 miles below the drilling site. Even that record is tiny on a planetary scale. Earth's mean radius is about 6,371 kilometers. Divide 12.262 by 6,371 and the result is 0.001924. Multiply by 100, and Kola reached roughly 0.192% of the way to Earth's center. On a globe with a radius of 1 meter, the borehole would be less than 2 millimeters deep. And it never reached the mantle. The boundary between crust and mantle is called the moho. According to the United States Geological Survey, it lies about 30 to 50 kilometers beneath continents on average, although the depth varies by region. Kola stopped at less than half of even the low end of that typical range. So why not simply keep drilling? The first major obstacle was heat. A 2026 review of ultra-deep drilling reports temperatures of about 180 degrees Celsius at 10 kilometers and 212 degrees at 12 kilometers in SG-3. Those conditions were much hotter than the project's early models expected. The deeper the borehole went, the harder it became to keep equipment and drilling fluids working reliably. The second obstacle was that deep rock did not behave like the rigid stone we see at the surface. Under high temperature and enormous confining stress, the walls could deform and close around the borehole. A drill is not just cutting a clean tunnel through static material. Engineers must continuously remove broken rock, circulate fluid, control pressure, stabilize the walls, and keep kilometers of drill pipe from twisting or failing. Depth multiplies every small problem. A tool failure 12 kilometers down cannot be reached by a technician. The drill string can buckle, vibrate, jam, or break. The path can deviate from vertical. Measurements, core recovery, cooling, and material strength all become more difficult while the cost of each additional meter rises. Kola also changed what scientists thought they would find. Seismic data had suggested a transition several kilometers down that many researchers associated with a change from granite-like to basaltic rock. The cores instead showed metamorphosed rocks, fractured by pressure and containing fluids at depths where simple textbook models had not expected them. The seismic boundary was real, but its interpretation was more complicated. The project ended in the early 1990s, after the Soviet Union collapsed and the technical and financial barriers had grown severe. It did not stop because drillers discovered a mythical underground void, heard sounds from hell, or approached Earth's core. Those are internet legends. The real limit was less supernatural and more impressive: heat, stress, deforming rock, equipment survival, and money. Could we drill deeper today? Probably, with enough funding and technology. Modern high-temperature electronics, stronger materials, improved drilling fluids, and better directional control can extend the limit. But reaching the mantle beneath a continent would still demand several times Kola's vertical depth. Reaching Earth's center would require more than 500 times Kola's record, and conditions far beyond any existing drilling system. Kola's achievement is therefore not that humanity nearly reached the center. It is the opposite. We invested decades, engineered an extraordinary machine, and drilled deeper vertically than anyone before or since. Yet the result remained inside Earth's outer skin. The record is a precise measurement of both human ingenuity and the scale of the planet beneath our feet.